welcome back to the Deep Dive. This is the Data Zen AI Podcast, brought to you by the Data Zen community.
It's great to be here.
If you're looking to cut through all the noise and really get a handle on the trends shaping technology, maybe even get that foundational knowledge so you can speak confidently about this stuff in, any high-level business meeting, then you're definitely in the right place.
Today we're on a really fascinating mission, I think. We're trying to move past those simple, sensational headlines about AI coming for all the programming jobs.
Right. AI will replace coders. We see it everywhere.
Exactly. And instead we want to unpack the much more complex and honestly often contradictory reality of AI's relationship with creating software today. It's a deep dive into two pretty different worlds.
That's a great way to put it. On one side, you have the career programmer, the software engineer who's building these massive critical systems. And then on the other side, you've got the curious, non-technical person,
Right.
the marketer, the product manager, the small business owner who just wants to build a small tool to solve a problem they have right now.
And our goal today is to figure out what AI actually means for both of them.
To do that, we've pulled together a really balanced set of sources. We've got stuff from major IT consulting firms like Future Code. We've got the big picture market view from Gartner.
And we even dipped into the cultural debates happening in developer communities. So technical discussions on Reddit, even the Wikipedia entry for a new term like vibe coding.
Yeah, we're trying to balance that, that breathless optimism of AI will do everything for me.
Right.
With the cold, hard technical reality of what AI can and, maybe more importantly, cannot do when a piece of software has to be secure, robust, and ready for real users.
It's so crucial because the context of who is using the tool and what they're trying to build, that changes everything. It's the difference between AI being this revolutionary helper or just a source of massive, massive technical debt down the line.
Okay, so let's start there. Let's unpack this with the role that I think for a long time most people thought was pretty safe from automation, the programmer. When we talk about AI taking over coding, what does it even mean to be a programmer or a software engineer today? Because from what I'm seeing in our sources, it's a lot more than just typing.
Oh, absolutely. The consensus from every single technical source we looked at is that the real value of a good programmer isn't knowing where to put the semicolon.
Right.
The role is really about a creative approach to solving problems and designing systems.
So it's not the individual words, it's the whole story, the architecture.
Precisely. You have to separate the idea of coding from architecture. An AI tool might be incredibly fast at generating a small logical block of code. That's the coding part.
Okay.
But the programmer is the architect. They're the one who organizes those blocks, connects them, makes sure the data flows correctly, and applies this really complex, high-level thinking to get the business result you want. The AI gives you the bricks, the human provides the blueprint.
And make sure the foundation won't crumble.
Exactly, and that it can scale.
So if that core architectural role is still human, how is AI changing the day-to-day for a career coder? What is this AI productivity boost we keep hearing about? Is it, a real quantifiable thing?
It is. The main thing AI is doing right now is acting as an accelerator. It's drastically reducing what our sources are calling developer toil.
Developer toil. I like that phrase.
Yeah, and it's just the tedious, repetitive, non-creative work that eats up so much of an engineer's time, and that distinction is key. AI doesn't take the creative problem-solving job. It takes the boring context-switching job.
Let's get specific then. Can we break down some of those really painful, time-sucking tasks that AI is now automating for developers?
For sure. We can really break it down into 4 key areas where these tools are having a huge impact.
Yep.
First up is just code generation and boilerplate. So tools like GitHub Copilot or Tab9, they basically act like a super intelligent pair programmer. They're amazing at writing all that boilerplate code and helper functions right inside the developer's coding environment.
So all the setup stuff you have to do every single time.
Exactly. Every time you start a new function, you have to import libraries, define a class, handle some basic error logging. It's not deep creative work, but it requires a lot of accurate, repetitive typing. AI just gets rid of that completely.
And that frees up cognitive load, right? A senior engineer shouldn't be wasting brain power remembering the syntax for a log statement when they could be optimizing a database query.
Absolutely. Which brings us to the second area of huge productivity gain, testing.
Ah, yeah. The part everyone knows is important but hates doing.
Right. Historically, writing good unit and integration tests is necessary, but it's incredibly time-consuming. It's the first thing that gets squeezed when deadlines are tight.
Which leads to more bugs in production.
Always. But now, tools like Quoto can automate generating those tests based on the function the developer just wrote. This shortens that feedback loop, you get higher code coverage, and you don't have to spend hours doing it manually. It basically institutionalizes quality control.
That's a huge operational shift. Automating testing means less risk, fewer late-night emergencies for the team.
It really is. And the third area is where AI goes from just assisting to being proactive, and that's debugging and security.
Okay, so finding problems before they become problems.
Exactly. Platforms like Snyk or GitHub Advanced Security are using AI to scan code bases and, importantly, all their dependencies. They'll proactively flag vulnerabilities, like flaws in third-party libraries you're using.
And they just tell you there's a problem.
Well, this is the critical part. Some of them don't just alert you. They suggest a quick, contextually relevant fix right there. So it strengthens security way earlier in the process, and developers spend less time manually hunting for bugs.
So you're moving from reactive fixing, waiting for a bug report, to this proactive, real-time code policing. So what's the fourth area? The one everyone universally dislikes.
You guessed it. Documentation.
Of course.
Developers are notorious for neglecting it, but AI can now bridge that gap. It can auto-generate really comprehensive stuff, readmes, doc strings, API references, directly from the code itself. This means the documentation is always up to date and accurate, which is a lifesaver for new hires.
It sounds like AI is basically just transforming all the grunt work into intellectual capacity. The goal isn't to write less code, but to shift the developer's focus to the more interesting problems.
That is the core takeaway. And when you look at quantifying the benefit, the numbers are pretty astonishing. For example, some teams using tools like GitHub Copilot are reporting they complete these repetitive coding tasks up to 56% faster.
56%. Let's pause on that for a second, because that's not just a small bump. That is a paradigm shift in how fast you can work. How does that even happen?
Well, the sources break it down into about three main mechanisms. First is just reduced context switching. Every time a developer has to stop what they're doing to go look up some basic syntax, they switch context. And that switch is cognitively expensive. AI removes that, keeping the developer in their flow state.
Makes sense. The second.
The second is the statistical nature of boilerplate. I mean, AI models are just amazing at statistical pattern recognition and boilerplate code, helper functions, test setups. It's all highly repetitive and predictable. The AI is just spitting out the statistically probable code block that, 99% of the time is exactly what you were about to type anyway.
And a third.
Time saved on API lookup. Before, if you had to use a library you hadn't touched in 6 months, you'd spend 10 minutes digging through documentation to find the right function name or parameters. AI just gives you the correct functional block immediately.
That speed doesn't just mean efficiency. It has huge implications for where senior engineers, the most expensive people on the team, are spending their time.
It does. It lets those senior engineers shift their focus almost entirely away from the low-level details. They can concentrate on architectural improvements, performance strategy, planning the next product feature, the novel, complex problems that AI still really struggles with. It frees up their brain power.
So, to sum it up for the professional coder, AI isn't a replacement, it's a force multiplier. It automates the boring part so they can focus on the high-value architectural problem-solving they were actually hired for.
That's the consensus, yeah. And it kind of means the bar for being a human programmer is actually getting higher. You need less syntax knowledge, but way more system-level judgment.
Okay, now let's shift gears completely. We've talked about the professional coder with their, $150,000 setup.
Yeah.
Let's talk about the person who's never even touched a command line.
Right.
This is where AI starts to really democratize technology, creating this whole new class of builder. We're talking about the rise of the citizen developer.
And this is a really crucial distinction that Gartner defines very clearly. A citizen developer isn't a formal job title. It's a persona.
A persona, okay.
It's an employee who reports to a business unit other than IT, so think marketing, sales, HR, and they create applications for themselves or for their team using tools that IT hasn't explicitly forbidden.
So it's someone who understands a business process inside and out, sees a problem, and just builds a little tool to fix it themselves without needing to file a ticket with IT.
Exactly. They fall under this bigger umbrella of a business technologist. And the reason this is exploding now is because AI, paired with all these no-code and low-code tools, has just demolished the barrier to entry. We have abstracted away all the heavy engineering.
Okay, we have to define no-code versus low-code simply because the market is flooded with these terms and they get thrown around a lot. How should we think about the difference?
The easiest way to think about it is in terms of flexibility. No-code is like arranging sophisticated digital puzzles. You're building an app with a purely visual drag-and-drop interface. You've got pre-built components forms, tables, integrations. The technical knowledge required is about the same as knowing how to use Excel formulas. It's perfect for simple internal apps, like a basic CRM or reservation system. You stay inside the platform's guardrails.
And low-code, where does the code part come in?
Low-code is a similar visual environment, but it gives you an escape hatch.
An escape hatch, like that.
Yeah, for when your business need is too complex for the standard parts. Low-code lets you inject custom code snippets or advanced logic, maybe a bit of JavaScript or a direct call to an external API. It just allows for way more complexity and customization. You're not writing the whole app, you're just patching in a small custom piece.
And the real power here is the speed, right? This combination of AI and these platforms, it's a shortcut to getting a minimum viable product, an MVP, out the door.
It creates a speed advantage that's almost unbelievable.
Yep.
And it completely changes the risk profile of innovation. MIT Sloan found that companies using no-code platforms can deploy applications up to 10 times faster than traditional methods.
10 times faster. That's not an iteration, that's a transformation.
It is, because it shortens that critical build, measure, learn cycle. You know, a startup might have taken 6 months just to build the basic product to see if anyone even wants it.
Right, and spend a ton of money doing
A
it.
ton. Now, you can get a functional prototype in front of real users in a week, sometimes days. The Founders Path blog we looked at points out that most startups fail because no one wanted their product. No-code drastically reduces the time and cost it takes to find that out.
So the goal isn't just to build the final thing, but to build a testable prototype fast. What are some of the tools that non-tech people are actually using for this?
The landscape is pretty mature now. For complex web apps like marketplaces, Bubble is still the big one. For quick internal apps, a lot of people use Glide. You can literally build a mobile app from a Google Sheet in minutes.
Wow.
Then for more polished websites, like membership sites, you see a lot of Software and Webflow. And then there's the most critical category for the citizen developer, automation. That's where you have Make and Zapier.
They're the glue, right?
They're the essential glue that connects thousands of different apps. So, you know, if something happens in your sales software, it can trigger an email and log in a spreadsheet, all without a single line of code.
Okay, this is all powerful in theory. Let's ground it. Do we have a real-world example of a non-technical person using these tools with AI to build something genuinely valuable?
We have a perfect one. A real case study of a creator who built a pretty sophisticated AI-powered data analysis tool in under 3 hours.
Under 3 hours, from scratch. Walk us through it. What did they build and what did they use?
Okay, so this person was a marketing strategist. They needed a tool to analyze viral TikTok videos to help with their client strategy, you know, to reverse engineer success. So they used a front-end platform called Lovable to build the user interface, and then an advanced automation engine called N8N, which is more of a low-code tool, to handle the complex logic and the AI calls in the background.
So Lovable is where you paste the TikTok link, and N8N is the engine doing the heavy lifting.
Exactly.
Yeah.
And here's where AI replaces traditional coding. Step 1, the user just drags a text input field and a button onto their Lovable canvas. Click the button, it sends the URL to the N8N workflow. Pure drag and drop.
Okay.
Step 2 is the core logic. In N8N, the marketer, acting as a prompt engineer, didn't write any code. Instead, they just wrote a detailed instruction for the AI. Something like, analyze this video, give me a full timestamp transcript, then analyze the success metrics, views, likes, engagement, and tell me the specific pattern that made it go viral, focusing on pacing and audio hooks.
That's a very specific prompt.
It has to be. The AI then sends back the structured data. The N8N workflow takes that and tells Lovable to display the results in a few summary cards, like key success factors and a viral strategy breakdown.
But here's the kicker. What's the final output?
The final step in the workflow instructs the AI to generate a new, customized prompt for the marketer, a script and an instruction set for them to create their own similar viral content. The marketer didn't code any of that logic. They just orchestrated the flow and wrote the instructions in plain English.
That is profound. It's not just summarizing, it's reverse engineering success and then creating a production-ready instruction set. And a non-technical person did this in an afternoon.
And the business value is immediate. The creator said they could monetize this tool in 3 ways right away.
Yeah.
Use it as a lead magnet to get new clients. Monetize it directly with micropayments for other creators to use, or just use it internally to make their own content better. The point is, the barrier to building something with real business functionality has almost vanished.
This really does shift the advantage from just raw coding skill to domain expertise. It's about your ability to identify a painful, expensive problem in your field.
That's it. For this new wave of citizen developers, the crucial skills are changing. It's less about technical syntax and more about critical problem solving, data organization, prompt engineering, and just having that prototyping mindset. You build fast, you test fast, and you iterate fast.
So this democratization of development is creating huge opportunities, but it's also leading to some interesting cultural side effects. And the one that seems to cause the most debate, maybe the most alarm bells for technical people, is this idea of vibe coding. I mean, this term has actually achieved real cultural status. Collins Dictionary apparently listed it as their word of the year for 2025.
It signals a really radical, almost philosophical shift in how some people are approaching software. The term was popularized by Andrej Karpathy, who led AI at Tesla and OpenAI, so he's a serious figure.
So what exactly is vibe coding? What makes it different from just using Copilot to help you write code?
The core technique is this. The developer describes a task to an LLM in natural language. The AI generates the code. And here's the crucial difference. The developer evaluates it only by running it and seeing what happens. They use the test results and feedback to judge it, but, and this is the key, without reviewing or editing the code itself.
Wait, hold on. Forget that the code even exists. Is that revolutionary, or is that just a fancy name for cutting corners? If you're just running the output and then copying the error message back into the AI to fix it, where's the human adding any value?
That is the exact criticism that people like Andrew Ng have raised. Karpathy's philosophy, in his words, was to fully give in to the vibes, embracing exponentials, and forgetting that the code even exists. He even admitted to using it for simple things like moving a sidebar, just because he was too lazy to find the right lines of code himself. He just hit accept all on the changes without even reading them.
I mean, I get the appeal for speed, especially for the citizen developer we were just talking about. What kind of adoption are we seeing for this?
Well, its main appeal is for what people are calling software, for one. You know, if you need a quick script to rename some files and you'll never use it again, it's fast. It's also a way for experienced programmers to quickly get a feel for a new language they don't know.
And we know this AI-first approach is moving into the professional world pretty quickly.
That's right. There was a report from Y Combinator that showed a huge shift. 25% of their winter 2025 startups had code bases that were 95% AI generated. Now, we can't say that was all pure vibe coding, but it shows a massive reliance on generative AI for core business assets.
But the danger here, the reason so many experts are pushing back on the term, is that fundamental difference between using AI to code and truly understanding the software you're building.
This is the heart of the debate. If an LLM writes all your code but you, the human, review it, test it, and you understand every single decision.
Yeah.
That's just using AI as a really fast assistant. Vibe coding specifically means accepting the output without full comprehension. And Andrew Ng pointed out that the term is misleading because it makes software engineering sound effortless, which is dangerous.
So what are the concrete, high-stakes risks of just letting the AI run on vibes when the software actually matters, like for a paying client?
The risks are pretty profound. It starts with just accountability and security. When you use AI-generated code without understanding it, you're at risk of introducing hidden logical errors, or worse, serious security vulnerabilities. The LLM is designed to give you functional code, not necessarily secure code.
Do we have a real-world example of this playing out? A security risk?
Yes. Lovable, that platform we mentioned earlier, actually had some security vulnerabilities identified in the code its AI engine was generating. Out of over 1,600 web apps built on the platform, 170 of them had an issue that could have let personal information be accessed by outsiders.
Wow, that's a failure rate of almost 10%.
On a critical feature like security, yeah. All because the developer, relying on the vibe, didn't know they needed to add extra human-driven security layers.
And I imagine it struggles with complexity, too.
Immensely. That's the second point. Generative AI is great at simple, self-contained tasks. But it really falls apart when you give it novel, complex problems, especially things that involve multiple files interacting or working with old, poorly documented systems.
You can't handle that big picture system architecture.
Exactly. And third, you have huge challenges with maintenance and debugging. Because the AI generates code on the fly, the structure and logic can be really inconsistent. So when a bug inevitably pops up weeks later, if you didn't write the code, trying to fix it becomes, well, what senior engineers are already calling development hell. It's the vibe coding hangover.
So the shortcut you take today becomes a massive technical debt problem you have to pay back with interest later on.
You're borrowing time from the future. And that's the final limitation. Software engineering is all about evolving and maintaining systems over time. If the code is incomprehensible because it has no consistent style, which often happens with pure AI output, it just cripples the team's ability to move forward. Vibe coding is incredibly risky for any production code base that needs to live for years.
So vibe coding really throws into sharp relief the difference between generating a block of code that works, which AI is great at, and creating software that's production-ready, maintainable, and secure, which still needs a human. Let's really dig into the hard limits. Where does AI still completely fall over without real human technical knowledge behind it?
Yeah, based on the consulting reports and developer forums we looked at, we can synthesize a few critical failure points. The first, and maybe the biggest one, is context and architecture.
It doesn't know the bigger picture.
Not at all. LLMs struggle so much with the specifics of a project. They're generalists. So they might suggest a perfectly logical piece of code that just doesn't fit your project's existing framework or its performance goals. And getting it up to speed would require you to feed it the entire project context, all the data schemas, the API specs, the dependencies, which for any large system is it's totally unrealistic.
So if you're working on a 10-year-old proprietary system, the AI has no idea that its brilliant new suggestion is going to brave some critical old component. The human has to carry that institutional knowledge.
Precisely. The second major limitation is code quality and optimization. AI can write code that's syntactically correct, code that runs, but it's not inherently optimized for performance or memory or cost.
It just wants an answer, not the best answer.
Right. It's up to the developer to manually tweak the code for speed or to give the AI highly specific technical instructions on how to optimize it. And that means you have to have a deep understanding of performance metrics yourself. You can't ask for what you don't know you need.
If you're not optimizing, you're just building a fast prototype that's going to grind to a halt under any real user load.
And that connects to the third point, which is a fundamental limitation of how these models are built. Knowledge and currency.
They're out of date.
They can be, yeah. LLMs rely on the data they were trained on. The classic example is that some older models, like GPT-3.x, had a knowledge cutoff of around June 2021.
Can you give us a specific example of how that would actually cause a problem for a developer?
For sure. Let's say you're a developer working in Python and you ask an older AI to write some code for secure web requests. The model, based on its 2021 knowledge, might suggest an old authentication method that we now know is insecure. Or it might miss a critical security patch that was added to the library in 2024. The code would work, but it would be dangerous. The human has to be the filter, knowing to override that suggestion and use the current, safer method.
That's a huge blind spot. And the fourth limitation, that's more about just general trustworthiness, right?
Yes. The fourth is hallucinations and errors. We all know AI models can just make things up. If you don't give it a very specific, constrained prompt, it might take logical shortcuts, invent functions that don't exist, or just include totally unnecessary code. The point is, AI code is not secure or correct by default. And because of this, which is why Stack Overflow had to temporarily ban ChatGPT answers, a human developer has to review, test, and validate every single thing it suggests.
Okay, let's circle back to our citizen developer, the marketer who built that tool in 3 hours.
Right.
Where do their no-code or AI platforms hit a wall when they try to go from a cool internal tool to a serious external business product?
They hit a very hard wall when they try to scale up. The discussions we saw on Reddit and in founder blogs were really clear about this. These platforms often just lack the crucial, heavy-duty features you need to run a real business.
What kind of features? What's missing?
We're talking about things like multi-tenant security, which is what ensures one of your customers can't accidentally see another customer's data.
That's a big one.
It's huge. Or sophisticated LLM token accounting and logs, so you can monitor and bill for how much your users are costing you in AI calls. And then just robust billing and payment support for different subscription tiers. These are serious architectural components that you don't get from a prototype quality AI output. That jump from a working script to a profitable, scalable business is where the human software engineer has to take over.
So this all brings us back to the big question for our listeners, whether they're technical or not. Can AI just replace learning how to program?
And the resounding answer from all the experts is no. AI is a tool for the programmer, but it can't replace the programmer. It just lacks judgment, it lacks empathy for the user, and it has zero accountability. The human is still needed for the design, for ensuring quality, and for aligning the whole thing with what the business actually needs.
So given that so many non-technical people are now using these tools, what's the pragmatic way to handle it? How do you manage that enthusiastic colleague who wants to write code with AI?
The consensus from experienced developers is actually brilliant. It's a balanced approach. Let them try, but mandate a thorough code review for everything they generate.
That's smart. It turns a potential fight into a learning opportunity.
It absolutely does. When you let a product manager or a designer generate a component with AI, they get firsthand experience of how hard it is. They learn really fast that generating the simple part is easy, but integrating it with the existing system and making sure it's maintainable, that's the real challenge.
So the code review maintains quality control, but it also teaches the non-technical person about all the complexity the AI just glossed over.
Exactly. It reinforces that AI-generated code is not production-ready by default.
So if the essential skills aren't about memorizing syntax anymore, what are the non-negotiable skills that both technical and non-technical creators need in this new environment?
Our sources point to 5 key skills, and they're mostly not about code. First is just problem-solving and domain expertise. The best apps come from people who deeply understand a problem. Second, the prototyping mindset, that build fast, test fast, iterate fast philosophy. Third is data organization. AI thrives on structured input, so understanding clean data is crucial.
And fourth?
Fourth is understanding AI's limitations. You have to know that it hallucinates, that it can be biased, and that its knowledge is dated. You have to be that human filter we talked about.
And the fifth skill seems to be the most technical of the non-technical skills, prompt engineering. People dismiss it as just asking questions, but it's more than that. Right?
Oh, it's way more. It's the difference between asking for a bike and asking for a high-performance bicycle with specific gears and tires. Good prompt engineering has 3 steps.
Okay.
First, you assign the AI a role and persona. You say, act as a senior Python developer with 15 years of experience in memory-efficient data processing. That sets the quality bar. Second, you give it output constraints and technical specs. You say, only use standard Python libraries, optimize for low memory usage, and provide unit tests using the PyTest framework. This forces the AI to address the things it normally ignores, like optimization.
And the third step?
Iterative refinement. The real skill is breaking a big problem into smaller prompts and then feeding the AI the context it needs, like existing code or error messages, so that its output actually fits into your project.
That is way beyond just asking a question. That's directing a very skilled but very narrow-minded assistant. So final question. As jobs shift, will we still need junior developers?
Absolutely. The roles will change, sure. We'll have more dedicated prompt engineers, but junior developers are still essential because they're the ones who learn the fundamentals, the architecture, the testing, the maintenance. They are the ones who learn the deep understanding required to ensure long-term success and scalability. They provide that essential human oversight that validates the AI speed. They don't just type code, they learn the language of systems.
Wow. We have covered a massive amount of ground today. From the professional engineer getting that 56% speed boost to the non-technical marketer building a viral analysis app in an afternoon, and all the way through the cautionary tales of vibe coding.
And the central theme is just so clear. AI is the most powerful accelerator we've ever seen for software, but it is not magic. It levels the playing field for getting started, but the barrier to building something robust, reliable, and secure, that remains very high. And it's guarded by critical human expertise.
So what does this all mean for you, for the new wave of creators? It seems like the biggest advantage you can have, whether you're technical or not, isn't your coding skill. It's your domain expertise. It's your ability to define and solve a meaningful, painful problem.
That's the one thing AI cannot generate yet. The vision, the empathy for the user, and the judgment to know if the system is actually any good.
Right. Use the tools aggressively, but master the fundamentals of problem solving and critical review. That combination seems to be where the real value is.
Unbeatable.
Thank you so much for joining us for this deep dive into AI, vibe coding, and the citizen developer. We really appreciate you tuning in.
And if you want to review any of the sources we pulled from, the tools we mentioned, the analysis from Y Combinator and Future Code, you can find the full article with summaries and links right now.
The link is in the description for this deep dive. And hey, if you found this conversation valuable, please let us know. Click the heart or the like button under the article to give us some feedback.
And of course, please subscribe on Spotify, Apple Podcasts, and YouTube so you don't miss our next one.
If you have a topic you'd love for us to unpack, send your suggestions to us by email or just visit us at datazen.top. Until next time, keep diving deep.